Terminating and non-terminating decimals. First, we will define what is decimal. So a decimal number can be defined as a number whose whole number part and the fractional part is separated by a decimal point. So we have here an example, 17 and 48. So it is read as 17.48. So the decimal point here is between 17 and 48. So the whole part is 17 and then the decimal part is 48. So notice that the whole number part is located on the left side of the decimal point and the decimal part is located on the right side of the decimal point. So the figure below represents the decimal 17.48 into figures. Okay, note that the digits following the decimal point or the decimal part shows a value smaller than 1. And also, decimal number can be classified as terminating and non-terminating decimals. Here's an example of how the fractional part can be converted into decimals. So we have here the whole part, which is 25, and then the decimal part is 6 over 10. So in decimal, it is equivalent to 0.6. For the next one, 6 over 100, or in decimal, it is 0.06, and 6 over 1000 is 0.006 in decimal. So how did we come up with these numbers? So simple, we just divided 10 with respect to its location on the decimal part. So if tens, divide by 10. If in hundreds, divided by 100. And if thousands, divided by 1000. Fun fact. Decimal fractions were first developed and used by the Chinese in the end of 4th century BC or before Christ, and then spread to the Middle East and from there to Europe. Numbers can be written into different forms which still its value is preserved. So we have here a fraction 1 over 4 or 1/4, where the number above the fractional bar or the vinculum is called the numerator, and the number below the fractional bar or below the vinculum is the denominator. So in illustration here, 1/4, so you take one part of the whole. So also, 1/4 is equivalent to 0.25. So we got this value by simply dividing the numerator 1 by the denominator, which is 4. So by using the division operation, we come up with 0.25. So converting fractions to decimal. So it is by dividing the top numerator of the fraction by the bottom or the denominator. So example 1, what is 5 over 8 in decimal form? So doing this step or this process, 5 divided by 8, so by the division operation, we get point 0.625 or 0.625. So for this case, we inserted extra zeros after the decimal point in 5 since it is less than 8 so that we can carry with the operation or with the computation. So just don't forget to write the decimal point, which is this one. So after the zero. So first you write 0 and then point, and then you go over with the computation. So therefore, 0.625 is the decimal form of 5 over 8. Another example, what is 1 over 3 in decimal form? Again, numerator 1 divided by the denominator, which is 3. So notice that the remainder of 1 keeps on appearing as we go on with the computation. So we can stop maybe on the fourth, since we can observe that the numbers just keeps on repeating or reappearing. So we can write it this way. So the decimal form of 1/3 is 0.3333 followed by 3 dots or the ellipsis, which means that the numbers, there are numbers after the last number written, which is 3. So the terminating decimals. So a terminating decimal is a decimal that has an end digit. So it is a decimal which has a finite numbers of digit or terms. So we have here examples. So 0.15, 0.86, 0.5, 2.456, and 23.456. So for the first example, we have two decimal places or two decimal digits, which is 1 and 5. For the next one, 0.86, two decimal digits. For the third one, 5, which is one decimal digit. For the fourth one, which has three decimal digits. And for the last example, we have three decimal digits. Now for the non-terminating decimals. So non-terminating decimals are the one that does not have an end term. It has an infinite number of terms. Okay, so examples 0.5444 and so on. 0.111 pi, which is equivalent to 3.14, 15, 92, 65, 35, and so on. So notice that it does not contain a specific number of decimal digits. So these are the non-terminating decimals. Let's answer this. Identify if 77 over 25 is terminating or non-terminating decimal. So for the solution and answer, we have here 3.08, which is terminating decimal. So for the solution, 77 over 25, and we got the value of 3.08. Question number 2. Identify if 308 over 9 is terminating or non-terminating decimal. So for the solution and answer, we have here 34.222 or 34.222 with a bar on the upper digits of 222, since we want to indicate that the 2 repeats itself. So notice that in our solution, the remainder 2 or the number 2 keeps on appearing. So we can uh, say that if we go over or continue with the computation, we will not come to an end, and so we can write this way instead. Question number 3. Identify if 17 over 8 is terminating or non-terminating decimal. For the solution and answer, we have the answer of 2.125, which is a terminating decimal. So 17 over 8, which gave us 2.125. Question number 4. Identify if 8 over 3 is terminating or non-terminating decimal. So for the solution and answer, we have 2.66 ellipsis, or we wrote it this way, which is a non-terminating decimal. Again, notice in our solution, if we go over with our computation, the number 2 keeps on appearing. So we can say that this is a non-terminating decimal. So this is the reference used in this presentation. Thank you.